Hello everyone. Today we are going to learn about Doppler effect. We observe the Doppler effect of sound in our daily life. And Doppler effect happens due to the relative motion between the listener and source of the sound. If the source of sound is approaching, we have more frequency, higher frequency, and if source of sound is moving away from the listener, at that time we have lower frequency. For example, the ambulance is in rest. In this case, the frequency of the sound is Fs is equal to the frequency of the sound we received, which is called Fo. O stands for observer and S stands for source. In other case, like if source is moving towards the listener or observer, in that case we hear the higher frequency than the source frequency. The observed frequency seems to be higher. It's called loud. When source is moving away from the listener, suppose this is Vs is the velocity of the source, it is moving away from the listener and frequency we received is less than the frequency of the source. And this change in frequency due to the motion of the source of the sound or source of the wave is called Doppler effect. Okay, in the Doppler effect, the frequency of the source will not be changed, but the wavelength we received will be changed. The wavelength is this, the distance between the two wavefront, right? This and this will be changed. If move away from the source, the distance between these two crests or trough will be large. And if source moving towards the listener, the distance between these two trough will be smaller. So in our case, we are putting the two scenario. One is the source is moving and second is observer in rest. Let f is the frequency of the source, f naught is the frequency we observe, and v is the velocity of sound, and let's say vs is the velocity of source. The basic idea is the frequency of source do not change. The frequency of the observer will be changed. The velocity of the sound will not change, and the velocity of the source will be changed. Let's say t is the time period of wave. The distance traveled in t by sound is tv. Right? Travel distance is which is tv. At the same time, the observer travel the distance this is, let's say the ds, which is t, and if source is here, it emits the sound. At the t time, the source will be in the another position. Let's say this is a, b. At t time, the source will be in the c position. Means from here, the observer can see the sounds is coming not from the a, but it looks like it is coming from the c. So there is change in wavelength, right? So wavelength is what? Wavelength is, let's say, observer wavelength will be the d minus ds, which is t b minus bs, and the time period is the 1 over frequency, and B minus Bs. And that's a new frequency. You observe the frequency is B by F naught, which is we observe the frequency by F B minus Bs, and so the observed frequency will be B over B minus Bs into F. This relation gives the frequency observed by the listener in terms of the source frequency when source is moving towards the observer, this direction. In this case, we have Bs equals to 0, then F not equals to F. The frequency of the source is equal to the frequency of observer. In second case, we have this part, B minus B divided by B minus Bs, which is greater than 1. This means frequency F naught is greater than F. When source is moving towards the observer, at that time observed frequency is greater than source frequency. In other case, like if source is moving away from the observer, so this is source, this is observer, is moving away from the observer. In this case, the Bs will be negative. So in this case, we have B F naught, which is the frequency of the observer, will be B divided by B plus Bs, and F is the frequency. In this case, F naught is less than F. Let us solve the one problem. In this problem, we have a siren emits the sounds of frequency 500 Hz. It moves towards the observer. Means this is siren, this is source, is moving towards the observer. And the speed of sound is given. Find the observed frequency. That means F naught equals to B minus Bs into F. In this case, we have F naught equals to what? Source of frequency is given 500 Hz, and the velocity of sound is given 340 meter per second, and source Bs equals to 20 meter per second. So observed frequency is 531 Hz, which is bigger than the source frequency, which is 500. Let us solve another problem. In this problem, we have a star which is moving away from the earth, and we observe the light with frequency 6.5 10 to the power 15 Hz. And now we have to calculate the change in frequency caused by the Doppler effect, because this star is moving away from the earth. So the idea is pretty much same. So let's see, c is the velocity of light, which is wave, and this equals to 3 into 10 to the power 8 meter per second. It is standard, and the frequency of source is given, which is 6.5 10 to the power 14 Hz, and the source is moving away from the earth. Us equals to 6.4 10 to the power 5 meter per second. We have a relation F naught equals to c, which is the velocity of light, c plus bs into f. Now we have to calculate the change in frequency. F naught by f minus 1 equals to c plus Bs minus 1. So from this relation we have f naught minus f equals to Bs over C, because C is very larger than Bs, so we can say C plus Bs is almost equal to C. So this is a change in frequency. So change in frequency is del f equals to Bs over C. So the f equals to Bs C divided into f. So if star is moving away from the earth, we get the frequency is decreased by 1.39. If the frequency is decreased, means wavelength will increase. That means in our light spectrum, this is the blue light and is the red light, which is read as high, and wavelength of blue light is always smaller than wavelength of red light. And the same way, the frequency of blue light is greater than the frequency of red light. So in this case, the frequency is decreasing, means wavelength is increasing, means this is moving from blue to red. So if you observe your star this year, right, and if you observe the same star in the next year, this frequency of the light is changing towards the red. This is called red shift. If the star is moving towards the earth, then the frequency will be higher, and we are seeing light is moving towards the blue from red. It's called red blue shift.